So our upcoming workshop, this is the last one for UPE Make. It's going to be Robotic Arm Kinematics. In order to attend this one, you need to be a member. But if you're interested in it, you can just let me know. And if you're not a member, we can induct you as a member. However, this workshop is also going to be completely remote. And we're basically going to be using a simulator to see how to program a robotic arm and how to make it move to where you want it to. You could use, for example, what we're going to do today in this workshop together with the robotic arm workshop. And if you had access to a real robotic arm, you could make an arm that can like move to where the object that you want to be is. So it would be like a cool project to have, right? But yeah, if you want to join our Discord, I'm sure many of you guys are already in it, but that's the Discord and this is our social media, especially the Instagram. We're very active there. Yeah, this is computer vision with Raspberry Pi. You can, I mean, if you, oh, sorry, I cannot hear you right now. 1 second. Oh, never mind. I'm tripping. Okay, so computer vision with Raspberry Pi. So you guys can see I have a Raspberry Pi logo here, but I also have a TensorFlow logo. And it's because we're gonna use TensorFlow for this workshop. There's a couple of reasons why TensorFlow is beneficial for us in this case, and you're gonna see. But what are we gonna learn today? And I already kind of told you guys, there's gonna be many cases. Wait, sorry, there's people also trying to come. Let me, just give me 1 second. Okay, I think you guys are all here. Welcome to the people that just came. You haven't missed much. I'm just introducing what we're gonna do today. But yeah, there's gonna be many cases. For example, robotics, or maybe you're creating a smart home sensor that is, okay. Well, sorry, I'm just keep getting distracted by the people comment. So yeah, imagine you wanted to create a sensor in your home. Maybe this sensor has a camera in it, and maybe you have a cat that always wants to go out. You could set up a camera that detects the cat, and once the cat reaches the door, maybe it can give you an alert or something. And that would be a cool case for this. Another one is, for example, robotics, especially when you have a robot that is not going to be close to a network. If you don't have access to a network, you cannot use cloud image processing like Google Cloud or all these cool technologies. You need to run the computer vision within the device, within the robot. And being able to do it with a Raspberry Pi is really cool, because a Raspberry Pi, even though it's more expensive than an Arduino, you can get one for $35, right? And it's pretty good being able to do computer vision in such a small embedded computer. But you cannot do that by default. You need to take some things into account, and that's why this workshop is so important. It's basically targeting computer vision for low power devices, which is useful for any robotics or anything that you want to do with, small computers. Not always you're going to have access to a big computer that can process, a powerful computer that can process all your machine learning or your object detection. So this is why it's cool to have the option to do it with smaller computers. So this is, again, a very, very rough intro to computer vision, and I apologize for the pixelated image, but I really like that one. Yeah, computer vision is basically a subset of AI, and it can be used, basically your vision. Yeah, man. I also am a glasses user though. But yeah, it's a subset of AI. I mean, many of you probably have already heard of it. It's very cool, especially when you see it working. Tesla's use it to detect the cars. the roads, the lines in the road and stuff, so they can do autonomous driving. But basically, some of the most popular uses for computer vision is object detection, image classification, pose estimation, and there's a couple more that we're gonna see in a little bit. But yeah, something to keep in mind is that computer vision uses convolutional neural networks, and you can see it here working. Normally, when you have a neural network, you only have one result at the end, but convolutional ones, as you can see, they basically extract the picture of the cat into its most important features, and that's how it basically works to differentiate different things, right? It extracts the most important features from an object. And that's how you train it. And that's how it's more reliable for computer vision. Before this, there were other methods that relied on creating outlines outside the object and stuff, but that wasn't very effective and it was very intensive. But now with convolutional neural networks, we're able to do amazing stuff just with a small Raspberry Pi. By the way, I'll show you guys my Raspberry Pi setup in a little bit, but yeah. Why use TensorFlow? Specifically, TensorFlow Lite is what we're gonna use today. Regular TensorFlow is very powerful. However, if you try to run computer vision with regular TensorFlow on a Raspberry Pi, it's gonna run at basically 1 frame per second. And that is very low performance, especially, I know, it's very low performance, especially when you wanna have something that is reacting to the environment in real time. So this is why Google, in this case, they came up with a light version to TensorFlow. And in order to understand what that does, it's good to know the difference. So again, this is very pixelated, but this is what a regular neural network looks like, right? We have the neurons in the network. Each one of them has a float value. As we know, floats are usually 32 bits. And processing a huge amount of 32-bit floats can be very intensive. So what they do with TensorFlow Lite is that they transform these float values into 8-bit integer numbers. The processors are way more optimized, especially the processor in the Raspberry Pi is way more optimized to calculating 8-bit integers rather than 32-bit float values. And what this does is this increases the performance in the case of our Pi by 4 times, just doing this change. And you may think, changing the numbers from floats to, from 32-bit floats to 8-bit integers may make the computer vision be less efficient, less accurate. But it's not true. What turns out with this is that the difference in accuracy is very small. Another cool thing about using TensorFlow is that Google is currently developing tensor processor units. And here on the right, you can see one of them. These are basically processors that are optimized to run 8-bit neural networks, just like this one. They're called quantized neural networks. And I have one of them here, but with the background, let me deactivate the background just so you guys can see this and the Raspberry Pi. Actually, it's my living room. My room. Wait. No, yeah, I vibe better in my living room, TBH. But this right here is a Google Coral, and this is a tensor processor unit. I can connect this to my Pi, and it goes from having 4 FPS in real time to having 30. 30 FPS in real time with a Raspberry Pi is impressive. especially for any kind of, you know, use case scenario that needs fast reactions. For example, if you were trying to do an autonomous car with a Raspberry Pi, I would recommend that you use this because then you can have faster reactions to whatever happens in the environment. But if you're okay with just having 4 FPS, you can run the Raspberry Pi by itself and just a Raspberry Pi camera. This right here is as expensive as the Raspberry Pi. So it's, I think, 40 bucks. I got it for 40. But again, you don't need to use this right here because you can create all your, you can train your model and you can implement it with a Raspberry Pi without this. And if you, at the end of the day, at the end of the project, if you feel like you need it, it's very easy to just convert your project to this. You use, and TensorFlow gives you already a tool that you use to convert the trained model to be compatible with the TPU. But yeah, it's around 40 bucks. So entirely, it would be like a Raspberry Pi with the camera, and this, it would be like around 100. But just the Raspberry Pi with the camera, it would be around 40 to 45. It depends on your use case, right? If you're just gonna be detecting your pet going to the wall, going to the door, you don't need 30 FPS. Oh, you're doing a project, Joel? Well, if you need it, at least to borrow it, let me know because I have an extra one. So, but yeah. So before I keep moving on, I want to show you guys the TensorFlow website. And still not bad. Yeah. And you can basically grab any TensorFlow model and convert it to a quantized one. And it's going to run in the Raspberry Pi at 4 times the performance that it would normally, which is normally is very slow, right? These are a couple examples that TensorFlow already provides you for Raspberry Pi. No, sorry, provides you for TensorFlow Lite specifically. As we saw, there's image classification, which is you give it an image and it tells you what's in that image. In this case, a banana. But object detection, which is what we're gonna do today, you can have more than one object in the image and it's gonna tell you what they are. It's also gonna tell you their location in the frame. Sorry, my model for my Pi is Pi 4. I wouldn't recommend doing this with a Pi older than the Pi 3 B plus or B, doesn't matter. 2B, okay. Well, let me know because I haven't tried it in the 2B. Maybe it still works fine. But maybe after this, if you try it, you can let me know if it works. Because I know it works because I have the 3 and the 4 and it worked well, but I don't know if it works well with the 2. But yeah, moving on. Again, this is another type of, this is all like related to computer vision, pose estimation. This is really cool. This reminds me of what they do with the Kinect. I'm pretty sure it's running a pose estimation algorithm and you could create your own Kinect with a Raspberry Pi, right? Similar-ish. And all of these examples, they have examples on GitHub. Like the entire model is trained already, and you can just grab it and use it yourself. Windows Kinect. I actually got a Kinect, but not for that purpose. I got it because of the 3D mapping that it does. And you can actually use that in robotics for creating a robot that maps the room that it's in. And it's very cool because the Kinect is not that expensive anymore. Speech recognition. This is the last one that I'm going to show you guys. Yeah, gesture classification. You can imagine you gestures with your hand and like that or whatever. It's going to detect it. So these models, they are actually like, the first two are for Raspberry Pi, the other ones are for Android. But these tutorials can be a little hard to follow, especially if you're getting started with Raspberry Pi and how to use the command line and everything. So there's actually this, resource. I'm gonna show it once I go to my Raspberry Pi. So I actually have my Raspberry Pi here. I have the Raspberry Pi connected to the power. I have a camera with a little...
Miguel, we can't really hear you.
Oh, sorry. Yeah, it's my microphone. Can you hear me now?
I can hear you now.
Okay, so yeah, this is just my setup. It's basically a Raspberry Pi 4 with a Raspberry Pi camera. That's it. And I actually, yeah, I am sharing the screen to my laptop so you guys can see it. And yeah, let's get started then. This is in the Raspberry Pi terminal. Sorry, the Raspberry Pi user interface, right? So something that you're gonna have to do before you're working with the camera is actually come here and do rasp config. Sorry, sudo rasp config. And I realize now that this is probably too small to see. So let me try something. Okay. 1 second. Well, for now, since most of the stuff that we're gonna do is programming, I'm just checking the code, how it works. Rasp config. I hope you guys can see. So yeah, if you go here, then you can enable interface options, and then you can enable the camera. And you enable it that way. Camera is enabled. I can see good. Okay, that's good. If you wanted to use the camera, and this is actually really important because if you wanted to do something like we did in our workshop, the Arduino Advanced, which is using I2C to communicate, you could communicate a Raspberry Pi with an Arduino using I2C, right? But you have to enable it first here. That's important. That's how you enable it. I already had my camera and my my I2C enabled beforehand. But something interesting here, and this is where, okay. Okay, here we are. So I showed you guys that you actually can access all these programs and projects from the TensorFlow website. However, to set it up on the Raspberry Pi, it may be a little tricky, especially if you're new. So I actually found this GitHub page, which is really helpful. This guy went through the trouble of basically setting all the dependencies and all the things that you need to download in an easy way to follow. And all you need to do is just follow the steps and you're gonna have it working. Now, since I know most of us are not gonna have a Raspberry Pi right now, and we weren't able to have our in-person workshop, what I'm gonna do is I'm gonna give you guys this link later in the Discord channel for Make, right? And or you can just look at it. Like it's TensorFlow Lite on Android and Raspberry Pi. So basically, we're gonna follow this through today. But if you want to do it on your own later with the Raspberry Pi, I would recommend using this guide. It's really good. It also tells you how to train your own models after, which is also really helpful. But yeah, if you see through here, and actually I'm not gonna do any of these things because I already did it beforehand. It takes about 45 minutes to install everything. But if you wanted to, all you need to do is grab your command line and start plugging all the commands that it tells you. For example, you would start at sudo ipt get update and stuff, right? And you would follow them all until the end. Again, this is there's not much to teach about this because it's just following. Exactly, it's like advanced. There's this literally, he created a file that is called by dependencies, and it's basically, it does all for you. But yeah, something that is important is in order to run this script, you need to enter a virtual environment. So I already followed this tutorial, right? If I see my main folder, my home folder, I think it's called, I have one file called Tfly, one folder called Tfly. So if I cd into it, Tfly1, then I can start the virtual environment that I need in order to run this. So to start the virtual environment is like this. And that's something you have to keep in mind because you're gonna follow this if you have a Raspberry Pi the first time and everything's gonna work. But the next time that you want to do anything with the computer vision, you need to run this line right here again. That's just so you can start the virtual environment every time. Welcome, Claudia. So once you start the virtual environment, and if you keep going down, tells you how to install the dependencies. This is gold right here because you don't have to install it yourself. And now this is interesting right here. Here he's basically downloaded the Google sample Dfly model. And this is something that you find in the Dfly website. That's what we saw in there, right? When you click get it for Raspberry Pi, they show you this. This is a quantized version of the very popular Coco SSD dataset. This dataset has a bunch of pre-trained objects and labels. We're going to be able to use it without having to train anything. And finally, he unzips it here and changes the name. This is all going to make sense once we see actually here in the main folder, you see Dfly. And here, exactly, sample model. This is what he did. He unzipped the dataset from here, and he created this folder. Inside there, you have the detect.tflite, which is the actual neural network, and then you have the label. Inside the label map, you get all the objects that we can actually detect with this dataset. You can see it's a lot. I know, right? Since the labels are set in order, there's going to be ones that don't have anything trained in them. And I imagine it's so you can train your own models in them. And that's why they just have, question marks. But yeah, you can detect persons, bicycles, car. You can detect pets, this is why I was telling that project about having a pet and maybe, if you want to see if it wants to go out or something, then maybe it sends you a notification on your phone. That would be cool. But yeah, you have a bunch of them. What I'm gonna do, actually, there's one that is keyword. I'm gonna have my keyword and it's gonna detect my keyword. But that's what we're gonna basically do later today. But finally, if you wanna run the model, you just use this line. So the first time you set it up, it's gonna work. The second time you set it up, you need to put the virtual environment, and then you need to run this line whenever you want to actually run the code. So since I already set my virtual environment, I'm gonna go ahead and try to run this, right? Yeah, let me get rid of this command line here. Yeah, if I run this, let's see what happens. Oh, okay. I was actually messing with the code a little bit. Let's take this opportunity to fix it and also show you guys how the code works, because it's a little scary the first time you look at it. However, okay, that was the problem there. So don't worry. I know it looks really long. I didn't write all of this either. I'm gonna just so we make it work first, and then I'll explain how it works pretty much. Yeah, let me just try it again. So now you guys can see me, sadly. But if I do this, it's also going to detect the keyword, and it detects a person in my hand, right? That is pretty cool. So what's happening right now? Well, first of all, you can notice how it's running at 4 FPS. Now, oh, that's a very appealing angle. No, but yeah, if you see, that just shows. Yeah, I'm holding my keyboard up. That's why it showed a person, because they have my hand in the frame. Now, if we go back to the, I also had this set up, but it's gonna make more sense. That was meant to be for the robot, actually. But if we look at the code, because it looks very long, but most of it is just setup that you don't have to understand, because it's part of the, basically the, like all of this is just setting it up so it works, right? Setting up, for example, here, you're setting up the video stream, which is basically the webcam. This is part of the example code that Google gives you. Then you have a couple parse arguments. This is when you're actually, I don't know if you guys remember, for example, here, you're giving the code the name of your model, your trained model. That's what is happening here, right? For example, that. So you're defining all the things, all the parameters that you can give that program. Then here you're setting those parameters to variables to be used later. This is just setting up the Google Coral if you need it. This is just going to set it up if you need it. As you can see, it uses Tpu. Again, this is all just set up, right? Nothing really is happening. However, what is TPU? TPU is a tensor processor unit, and it's a processor that Google and probably other people, but Google especially is developing now. You can use TensorFlow with a TPU like this one, and they are basically optimized to run AI models at 8 bits instead of 32, and they run them pretty fast. So even though my Raspberry Pi now is gonna do 4 FPS, if I connected this, it's gonna do 25. So it's definitely a sizable difference. And I know that in their, yeah, we will later today at the end. But I know, for example, Google Cloud, they're using massive like versions of TPUs pretty much. That's what they use for their cloud. It wouldn't run Crispier because Crispier is the resolution of the camera, and I'm using the worst camera ever, which is the Pi camera, right? But it's very cheap and it works easy with the Pi. You can set up, actually, never mind, the Raspberry Pi camera can do 1080p. And here, one of the arguments is default resolution 1280 by 720. So less motion blur it's gonna have, because if you're working faster, if you have 30 FPS, you're gonna have less motion blur for sure, because it's grabbing, you're getting more data. And again, it's not gonna show very well, especially here, since I'm not like actually running my Raspberry Pi. I'm running it through the network and sharing the screen. Let's just connect it and see what happens. Whatever. Let's see. Right now I have my TPU connected, and let's see if it performs better, which, I mean, it will, but this is the different script that you have to run if you have the TPU, and it's down here. It's this one. So oh no, I got the wrong one. Still 4 FPS. So if you run it with this one instead, Let's see what happens. Will it run? It does. But it runs at 20 FPS. However, it's not very stable through the network. Even though it's running at 30 FPS, what's happening is I'm sharing my screen through the network, and that's why you cannot see it. But just trust the FPS, I guess. This is the best that I can do, because if not, I cannot really do Zoom through the Raspberry Pi. That would be really, really tough. But yeah, I think for this workshop, it's just a proof of concept, right? So let's just run it without the TPU. But yeah, going back to the code, because I just want to show you guys more or less what, especially if you want to grab this and create a project tomorrow, what you really have to look for. And yeah, if you want more resolution, you're just going to change the default to a bit higher resolution. In this case, it would be 1920 by 1080. But you have to keep in mind that the performance is going to be lower. You know, the more pixels you add, the lower the performance. If you made this a smaller resolution, you will actually go up in FPS. That may be something that you may consider. You know, maybe your project doesn't need that high of a resolution. At the end of the day, computer vision neural networks, they grab your image and they compress it down to a way lower resolution anyways. So maybe you're not doing that much of a difference in the accuracy by lowering down the pixels, you know? But yeah, if we go down here, this is what actually is important. You see here, you have a while true. This is the main loop. This is what's running. This is what's running every frame, or in our case, once every 4 seconds, because we're running at 4 FPS, right? But it runs every frame. At the beginning, we're just defining the frame, which is the image of the camera with the video stream. We don't care that much about this. Again, this is all just converting that image into something that TensorFlow can actually process. Here, you're actually giving TensorFlow that image. And then here you're returning, and this is what actually is important. Here, TensorFlow gave you back, you gave it a frame, right? And TensorFlow gives you back data. That data is after the computer vision happened. So you have 3 types of data that it gives you back. Boxes, which is basically the, the coordinates of every square. Then you have classes, which is the name of the object that it detected. And finally, score, which is the accuracy level. Because you can get, your object detection can tell you, yeah, that's a human. But it can tell you that it's only 50% sure that it's a human. So that's something to take into account. And basically, after that, we have a for loop that is going to loop through all the scores that you detect every frame. Because every frame, you're going to give TensorFlow some image, and TensorFlow is going to return back data for every object. So there may be more than one object. That's why you have to look through all the objects that TensorFlow detected, right? So yeah, just 1 second. So yeah, we're looping through all the scores, basically. If you only have one object, this loop is only going to run once. If you have more than one, this is going to run more than once. Now, if that object has a score that is greater than the threshold, so what is this threshold? Well, if we look for it, here, that threshold comes from this. And what is that? That is actually defined here. So one of our arguments is how accurate do you want your model to be? In our case, our model is going to show us anything that is more than 50% sure that is actually what it thought it is. So if you want a model that is very accurate, and let me turn on my light. Here, back. If you want a model that is very accurate, you would bump this to 8, for example, and it's only going to show objects that is 80% sure. But yeah, I don't care that much about accuracy right now, but that's something to keep in mind, right? So yeah, if whatever score found is greater than 50%, accuracy, and it's less than 100%, because there may be scores that give you a wrong value. So this is just to avoid bugs. You cannot get something that is more than 100% certainty, of course. Then you're gonna create 4 variables. These are very interesting, because this is how you create the rectangle. And this is how you can actually locate an object for other uses, right? So if it finds an object, it's gonna tell you their location within the frame. Now, imagine, I'm gonna go back to the presentation, because I just thought it would be cool to have that. So imagine, yeah, let's just use this right here. So imagine your screen, because we saw our screen is down here. Sorry, 1 second. Our screen on the bottom, this right here is 7. Okay, we cannot see that. 1 second. 1280 pixels by 720 pixels. 720, right? That makes sense. That's our script. That's our image. So if we detect an object, and this object is going to be, for example, here, and I want this to be green, x min is going to be this distance right here. This one. X max is going to be this. Y min is going to be this. And Y max is going to be this. So the variables x min, x max, y min, and y max are just a value in terms of pixels. So I imagine x min in this case is going to be, for example, 300 and something, and maybe x max is going to be 600 and something, and stuff like that, right? That's how you draw the rectangle. And that makes sense. And it's important, especially because if you want to create, for example, a robot that is going to try to follow, for example, my keyboard, right? The robot tries to follow my keyboard. Then I want the keyboard to be in the center of the frame. So I can actually detect, I can actually draw. Let me see if I can. There's actually a very simple math equation to find the center of a cube, for example. And it's basically you add x max plus x min, and you divide it by 2. And that's going to give you the coordinates of the middle point of that square in terms of the actual frame. And then if this middle point, and let me just change the color to red. If that middle point is greater than half, then you can tell the robot to move left. If that middle point is less than half the width of the screen, then you can tell the robot to move right, if that makes sense. That's basically what I did actually here in the code. So if we go back, I have midpoint x, and I just did x min, x max, over 2. And then if that is greater than 700, turn right, less than 580, turn left, else just stay still. If you guys have any questions, let me know. But that's how you need to start thinking in order to actually use computer vision for a real project like this, right? But now, what if I have more than one keyword, right? What if I have 3 keywords? How is my robot gonna know which one to follow? Or something that happens also is sometimes the model detects your keyword 2 times. You know, your robot cannot follow 2 keywords at the same time. That just makes no sense. So an approach that you can use for that is actually just use the keyword that has the highest accuracy, right? So this is something that I'm doing here at the end, and it's basically this variable called object name. In this variable, I'm storing the name of the object that I have detected, and that's what basically prints it in the camera when we see it. Basically, you know, when I put the keyword up, it says keyword and then a percentage. Well, the name keyword comes from this variable. And I actually just created like a simple logic here. If my object name is keyword and the score of that keyword is greater than the previous best score, then just store the index of that class pretty much. Because hear me out. If you have more than one object detect in a frame, for example, you have 4 objects detected in a frame, this loop is going to run 4 times, and you're going to have 4 indexes, right? It's going to go from 0 to 3. If the third index is the keyword that has the most, then I want to be able to store that so I can use it later for my simple turn left and turn right logic. Yeah, again, this is a very simple and rudimentary approach to getting the best object, the one with the biggest accuracy. But yeah, I was basically having 3 variables here. One of them is a Boolean that, you know, is the best for found, because you may have cases where there is no keyword, right? So that's why that is there. Then the best score index and then the previous best score. They were all initialized to 0. And every frame, if there is a keyword or more than one keyword, we're basically going to be checking them and putting the one with the highest score as the one that we're going to use. After that is done running, I basically, you know, if there was a best score, then I'm going to repeat the process that we did before for finding the coordinates of the square and then the label name, right? Okay, I think it crashed. Oh, never mind. We're just a little laggy. Yeah, basically I'm retrieving back those 4 coordinates, which I actually don't need the 4 of them. I'm only using x min and x max. And the name, and then I'll use that, right? For example, midpoint, x min plus x max over 2, and this is how the robot stays, like trying always to grab the object and have it in the middle of the frame. If you wanted to have something that instead of moving horizontally, moves vertically, or both at the same time, you would need to create a midpoint for y. And yeah, would it be y? Yeah. That's, for example, if you have 2 servo motors connected to a camera, you could have the camera moving up, down, and left, right at the same time, you know? And that way you could have a camera that follows your face or something. Or maybe your pet. Maybe you have a gun, a Nerf gun, connected to the camera, and it just shoots at people, like Nerf, like a prank or something. I don't know. That was, yeah. I would really like to put a Nerf gun in one of these. Yeah, right. Maybe put a Nerf gun in the makerspace that just follows people. But yeah, I think because we're already in the hour, and I don't like making these workshops more than an hour. Since I don't have the robot right now, I cannot show you guys the robot following things, but I will send a video if you're interested. And if you do try this out and you run into any problems, you can always reach to us, especially through the Make chat. We're more than happy to help. Um, this is just the best resource that I found for doing this with the Raspberry Pi. You don't need to understand everything that's happening. You just need to grab the variables that are useful for you and use that in your project. And that's it. Thank you guys for coming. I hope it was a good workshop. And yeah, I know maybe I went a little too much into detail, but um, I think we could use this in the future for UPE Make for other projects. I know I was always planning to do a robotic arm, like a real one for the makerspace. So maybe we can have an arm that actually grabs things, like you would put it like cubes in front of it or something. And the Nerf gun, also great for sure. Or just we create our own little pet robot and it just follows people around. I don't know, that would be kind of cute. But yeah, for Joel, just DM me on Discord and I'll help you. I'll help you with the Coral stuff. But yeah, thank you guys. I'll stop recording. Have a nice Friday.
Thank you.